Hello students, I am your Rajni ma'am and today in this session we are going to see about the classification of elements. So we are dealing with class 9th chemistry chapter 2 is matter around us pure. So already in the previous session we have seen what are elements and the properties of elements. So now let's start with the video. So the elements are classified into metals, non-metals and semi-metals. So first we will see the difference between metals and non-metals. So in this, let's start with the characteristic of metals. So metals are malleable and ductile. So why metals are malleable and ductile? Dear students, we know that metals have metallic bonding. So in metallic bonding, electrons are delocalized. Delocalized, that means it's keep on moving and move freely among nuclei. When a force is exerted in the metal, the nuclei shift, but the bond do not break, giving metals their characteristic malleability and ductility. So that's why metals are malleable and ductile. Now let's see the second characteristic. Metals are hard, generally solid in state except mercury, gallium and cesium. So we know that why metals are solid in state. This is because in metals the atoms molecules are tightly packed. Why they are tightly packed? Because of the strong force of attraction between the molecules or atoms or the particles. So that's why the metals are generally solid in state. But what happened with mercury? Why it is in the liquid state? So mercury has unique electron configuration which strongly resists the removal of an electron, making it behave similarly to noble gas elements. As a result, mercury forms weak bond and is liquid at room temperature. Now let's talk about gallium and cesium. Gallium and cesium melts with the temperature of the palm. That means if you will keep it in your palm, it will melt and become in liquid state. Now third point, metals are electropositive elements. Now what does it mean? It means that metal have tendency to lose electron. Let's take the example of sodium element. So sodium is a metal. What is the atomic number of sodium? That is 11. So if you will write the electronic configuration of sodium, what it will be? It is 281. That means in valence shell of sodium, one electron is present. Now if sodium will give this one electron present in the valence shell, it will get the configuration of neon. Neon is a noble gas. So it is stable. So definitely sodium also want to get stabilized. So it will give the one electron present in the valence shell. So that's why we can understand from this the metals are electropositive and have the tendency to lose electron or donate electron. Now let's see the next characteristic. Metals are sonorous. Sonorous means they will produce a ringing sound when they will be beaten. So why metals give the sonorous sound? Metals are sonorous because electron bonding in metals are highly delocalized due to very low electronegativity. So that means metals are highly electropositive and very low electronegative, and the electron present is highly delocalized. That means it is keep on moving within the metal. Okay. Now next, metal has shiny surface, that is metals are lustrous. So gold is yellow in color, copper is shiny brown in color and rest of the metals are grey in color. So they are lustrous. Metals have high melting and boiling point except mercury, gallium, cesium and potassium. Now why metals have high melting and boiling point? Because of the strong force of attraction between the particles of metal. So that means you need to give more energy to break the bond between these particles. That's why the melting point and boiling point is high in the metal. Now let's see the another characteristic. Metals are good conductor of heat and electricity. So silver is the best conductor of electricity, and lead and mercury is poor conductor of electricity. So why metals are good conductor of electricity? Because of the free electron present in the metal. So these electrons conduct the electricity. Now let's see some important fact, some interesting and important facts about metals. So most reactive metal is francium. The heaviest metal is osmium. The density you can see it is 22.57 gram per ml. The lightest metal is lithium. Density is 0.534 gram per ml. Metals having low melting point is mercury. Metals having highest melting point is tungsten. Most poisonous metal is plutonium. Metal which is in liquid state, we all know that it is mercury. Best conductor among metal is silver. The poor conductor of is among all the metal is lead. Coinage metal is your silver, gold, copper. Noble metal is silver, gold, copper, rhodium, iridium, osmium, platinum, palladium. All these are noble metal. That means their reactivity is very low. They are least reactive. That's why they are kept under the category of noble metals. Then most malleable metal is gold. Most ductile metal is silver. Most abundant metal you will get in the earth crust, that is aluminium, and most commonly used metal is iron. Now let's see the characteristic of non-metals. Non-metals are electronegative elements. Now we have already seen what is electropositive elements. Now let's discuss electronegative elements. So non-metals are electronegative elements. That means they have tendency to gain electron. In non-metals they are electron deficient, means उनको electron की ज़रूरत है. They are electron deficient. So definitely those who will be the devoid of it, those who are having deficient of it, they will need that. So that is in the case of non-metal also. So they are having the less electron than their requirement. So they need more electron. So tendency to gain electron is electronegative. So non-metals are electronegative in nature. Non-metal except graphite are poor conductor of heat and electricity. So why except graphite? See, graphite is a allotrope of carbon. Okay, and this graphite, if you will see the structure of graphite, so you will see in graphite the carbon is present. So carbon is tetrahedral. So that means carbon can form 4 bonds, but in the case of graphite each carbon is connected with the other carbons and one of the bond is free. That means one electron is free in the graphite of the carbon. So this free electron can move and conduct electricity. That's why only graphite in the case of non-metal is conducting electricity. Otherwise non-metals are poor conductor of heat and electricity. Non-metals are non-malleable and non-ductile. Why? Because they do not have metallic bonding. So they are non-malleable, non-ductile. Non-metals are either solid, liquid or gaseous at the room temperature. So we know that carbon, sulfur and phosphorus are in the solid state. Bromine is in the liquid state, whereas oxygen, hydrogen, nitrogen are in the gaseous state. So all this state is present in the case of non-metals because the force of attraction between the molecules are very less, and that's why you will get to see the different states here in the case of non-metals. Then non-metals are non-lustrous. Non-metals are generally soft. The reason already we have discussed why it is, because of the weak force of attraction between the molecule. Non-metals have low melting and boiling point. The same reason is for this also. Now let's see some of the very important and interesting fact about non-metals. Most reactive non-metal is fluorine. Non-metal having lowest melting and boiling point is helium. Non-metal having the highest melting and boiling point is carbon as diamond. Non-metal which is in the liquid state is bromine. Non-metal which is best conductor of heat and electricity is graphite. The non-metal having metallic lustrous is iodine and carbon. In carbon, that is diamond only. Diamond is the allotrope of carbon. Then heaviest non-metal is astatine. Lightest solid non-metal is boron. Now the last topic of this video is semimetals. The elements which behave both like metals and non-metals are called semimetals or metalloid. These elements have intermediate properties between those of metals and non-metals. They were previously called metalloid, but now we are not using term metalloid. Earlier we were using this term metalloid, now we call it as a semimetals. So what are the examples of semimetals? So semimetals, the examples are like germanium, silicon, arsenic, antimony, selenium, tellurium. So these are the examples of semimetals. So thank you class. Study well. Have a great day.